Welcome. It's great to have you all here with us. You know, a great scientist or inventioneer should be helpful, but they should also know how to have some fun. You know, that's why I'm advocating for you to set your Wi-Fi password to "It's on the fridge." That way they go and look on the fridge, but there's nothing there. No, it's on the fridge. Okay. You know, a little bit of fun. Well, a little bit of science news today. Researchers at Edith Cowan University have been doing a study, and they found that just 5 minutes a day of eccentric exercises could dramatically improve people's lives if they had a sedentary lifestyle. And I say, well, if 5 minutes, what about 30 minutes? But even better. But so when they say an eccentric exercise, they don't mean like, you know, a strange exercise. They mean the kind like when you're stretching and extending certain muscles, like if you were sitting in your chair really slow. That's why some of us can, you know, say, no, I'm working out, you know, when you're sitting down. But they're finding that certain kinds of exercises that build some muscle actually have real health benefits, you know, to your physical and mental health, and it's pretty important to incorporate some exercise. Kind of reminds me, the other day, my son told me, I saw somebody do 50 push-ups. Do you think you could do that? And I said, well, I don't want to brag, son, but I'm pretty sure I could watch somebody do 100 push-ups. So. Well, it's time to get the very latest in Acellus news with Dr. Joshua.
The science fair is just around the corner, and there's enough time that you can put together an awesome project. You know, how do you come up with a good science fair project? In ScienceLive several weeks ago, Dr. Billings talked about how choosing a topic that aligns with something you're passionate about or interested in is a great place to start. Maybe you're really interested into hydrogen, or what if you were interested in garlic? Here are some highlights from past science fairs that may give you some ideas for your project. Take a look.
Can I use hydrogen to take the chlorine out of water to make it safer to drink? On our cycle 1, we started with 0.4 parts per million. After we ran it again with hydrogen, then it came out at 0.1 parts per million.
Have you ever wondered if there was a superfood with amazing antibacterial properties? But we have one. Garlic, the Allison powerhouse.
Why do some notes sound so good together and some don't? I've been trying playing some notes on the piano, and when I play these 3 notes, they sound good. But when I play, for instance, these notes, they don't sound good.
Hello, I'm Maximo, and I'll teach you how to do a water wheel.
And my question is, does hard-nut garlic eliminate bacteria more effectively than soft-nut garlic? 3 days into the experiment, we took these pictures. The hard-nut has an extremely defined ring around it, where it killed that bacteria.
3D printed 3 mouthpieces, each with a different size rim. I'm gonna try each one.
My science fair project is about conducting electricity.
Hello, my name is Rija Chervuri, and my project is titled Using the Coding Language Python to Create a Computer Program That Can Diagnose Eye Cancer.
So now you know about garlic, the Allison powerhouse. Oh, and one minor fact, it's tasty too.
Well, the deadline is coming up April 23rd. We can't wait to see what you'll create. Thank you.
Well, now it's time for Dr. John with the Technology Spotlight.
Nice intro. Oh, wouldn't you love to have a machine that could just make whatever you wanted? You know, you just push the button and it runs and out comes what you want. Well, we kind of have that with 3D printers, right? You know, they'll 3D print whatever you want. The problem is, quite often, once it's done, you have to put it together. And even worse, if you're trying to print something neat, like a robot, then you have to have electronics. And the 3D printers, at least the kinds that you and I can afford, just are plastic, So it's kind of a problem, isn't it? Well, researchers at UC San Diego have taken this on with a different approach. What if we didn't need electricity? Check this out. This is a robot that they made, and you'll notice on its back it's got a cylinder of air. It's a pneumatically powered robot. It means it runs on air, and it has no electronic parts, but you'll notice that it's moving autonomously, moving those legs. So how in the world did they do it? And I want to show you a diagram that shows the special pneumatic switch. They call it a pneumatic oscillator that times and controls the legs. And there's two stable states. And on the top is one, and then the bottom is the other. And those yellow sections inflate with air. They're like little bags of air, and it transitions between them. If you look carefully up in the upper left side, you see where it says open. See how that tube is letting air through? Then if you look in the lower left side, it's closed. And they have this really nifty way of opening and closing the tube. They just smash it, it closes, and then back and forth. It's kind of hard to see how it works in this diagram, so I want to show you a video of it running. So here's one of those switches, and you'll notice how it snaps back and forth between the states, and you can see the little tube getting pinched on one side, and then as soon as the bag is full enough with enough pressure, then it flips to the other side. And that allows them to keep time and to control the movements. So all you need on top of that is to have 4 states. So they have to have another one of these switches, and the legs can flip between the 4 different states to walk. So here's a video of them testing it. Put the air in, and with nothing but a source of air pressure, it can move between these 4 different states and actually do the walk cycle. And it's pretty impressive that they can do it all with air with no electronics. But the neatest part is that it can almost walk off of the 3D printer. And so here is a video of them 3D printing it. And they use TPU material, which is a pretty common 3D printing kind of plastic. And it's going pretty fast, but if you look down in the corner, it shows how many hours it was running. 58 hours. It took quite a while to print. But then, after that, they have to do the assembly. Let me show you that. So first, they have to take it off of the 3D printer, and that is probably the hardest part. And then just clean it off. I guess we have to move the camera here to show that we didn't do anything in between. And then hook up the air and turn it on, and off it goes. Nothing else to it. That's pretty amazing that is all the way ready to go when it comes off the 3D printer. I'm so used to having to put them together, put the screws in, put the motors in, and all the extra stuff. But someday maybe we'll have this as something that we can use all the time. It just comes off the printer ready to use. Here's another video of it at the beach. And they're showing off how it doesn't have any electronics, so there's not much to get ruined in the water. It does kind of look like it's drowning, but those are those bubbles are actually it running, and it can work just fine underwater and in strange environments. So you're probably starting to wonder, well, now how would we use this? And I was wondering some of that too. But the researchers were pointing out that because it's pneumatically driven, it would be able to operate in environments where electronics might not. For example, in a really, really high radiation situation. And I can imagine, if it just walked in there, and that wouldn't be too useful. But I can imagine them having an airline that goes to it with controls, and they would be able to have all kinds of movements that it would be able to do. So there are a lot of interesting applications, but it's amazing that they can do that much with just little air oscillators turning on and off. When you think about it, that's actually the kind of stuff we normally do with electronics, but here they're doing it all with air. And so, you know, it makes me want to take a deep breath and think of more things we can do with air. That's all the tech we have the time for.
Now it's time for Breakthrough Moments in Science with Tobias.
You know, things change as time progresses, you know, as you get older. I remember when I was young, I had an imaginary friend. Now it turns out I have hundreds of imaginary friends, thanks to Facebook. It's like, but you know what's interesting to look at is how time has changed. Now time, of course, time is just the passage of time, right? I'm talking about how we measure time. Because, you know, to us, it's just a matter of, you know, keeping track of how much time has passed, right? Like if you look at this hourglass, this was a method of keeping time. Like there used to be church pastors over 100 years ago, and they'd use these to make sure they didn't go too long. It was a long-winded talk. But this is time passing, right? So it becomes, how can we measure time? Now, of course, in our time, we have hours, minutes, seconds. So the tick-tock of measuring time, you know, you think about like those pendulum clocks, the famous, you know, tick-tock. You're taught in school, 1 elephant, 2 elephant, how to count by seconds, okay? Well, the tick-tock is a way of measuring the length of a second so that the minute hand can move at the right speed, right? Now, of course, you can't exactly wear a pendulum on your wrist very well. If you move, it'll mess up the swinging. But if you think about it like on a ship, if you have a pendulum clock on a ship and as the waves move the boat, it'll change the pendulum and it'll get off. And that's one of the big challenges is getting time measuring systems that don't get off. Because if it's barely off, maybe it's just longer than a second or just shorter than a second, that adds up. And pretty soon, you're way off. Now, it didn't used to matter as much because, you know, it was just like, the sun is up, let's get some food. But then it started to get into technology and like the train will leave at 10 o'clock and we are having this meeting at this time. And all of a sudden, it mattered how on time you were or if you were late. And so being more accurate in our timekeeping got more and more important. Well, we're going to talk about some clever ways that the industry of watchmakers, because they're trying to get something you can carry with you, to have a mechanism that kept your time more accurate. The first one we're going to talk about is Bulova. And this is a company that was started in New York. And of course, we know this brand now. They have some nice watches, but they had an interesting idea. And that was, okay, so we need something that will move at a very consistent rate. And they had the awesome idea to use one of these, a tuning fork. Now this is, I'm going to hit it on this mouse pad here, see if you can hear it. Let's do it again. That is a C, folks, in case you didn't know. It says C256 because it's vibrating at 256 times a second. And they thought, man, if we took a tuning fork and shrunk it down, put it in a watch and had an electronic system in there that vibrated the tuning fork, we could figure out how to use that vibration to convert into moving the second hand. And they actually successfully made this. Here's their watch that they made, and it was called the Accutron. And they actually had some real success with this. They had a tuning fork in there, and it would vibrate 360 times a second. And they were able to use that. I'm not going to get too far into the mechanism because this is the big breakthrough, but this is an important step. Now, there were some catches. It would start to get off sometimes if there was too much movement, if the temperature changed sometimes. And then also, there was a slight, it's a tuning fork after all. So it's like, there's a fly around me. I could not hear it. But if you put it to your ear, you could hear a little 360 hertz sound of because it was literally vibrating. And so that was a bit of a turnoff for most people. And that kind of slowed it down. And eventually, they stopped. And you can now get a homage to it. And it looks similar, but they actually changed their logo. And if you've seen Bulova's logo, it's a tuning fork because of this system that they made. And it was kind of this incredible breakthrough. So we have this. It kind of worked. It was a really clever idea. Now, we have to jump back in time to somebody that made a really important breakthrough. In fact, two guys. First, these two guys, the Curie brothers, and they would discover the piezoelectric effect. Now, one of those brothers, you know, we got Jacques and Pierre. This is the Pierre that married Marie Curie. Okay, he'd want us to know that. Okay, but they discovered a really interesting discovery in the 1800s, and that was this effect on certain kinds of crystals, especially specifically quartz crystals, that if you applied a pressure to a quartz crystal, you could measure a voltage off of it. So wait a minute, I have a crystal and I hit it and I can measure a voltage. You had to have it cut in the right way and do it right, but you could get a voltage off of doing something to a crystal. And so that's a little discovery, and then eventually it would also be discovered you could flip that. Okay, so wait, so if I pressure the crystal, I get voltage, a little blip of voltage. What if I put voltage back at the crystal? And it was found that the crystal would actually vibrate. It would move from the electric voltage you put in. Okay, so, and that kind of, it was a neat thing, but it was like, well, what do we use it for? Well, we're going to talk about this guy, Warren Marrison. And in the 1920s, he thought, if I could use that vibration, and he starts studying how crystals vibrate, and he notices something really important. They don't just vibrate. Turns out they will vibrate at a perfect rate, a perfect speed of vibration. And he realizes, whoa, we could use that for clocks. If I could somehow take this vibration into the second-hand movie. So he actually makes a clock, and here's one of his clocks that has a quartz system inside that is being used to make that second-hand tick. Now, that's a little big for your wrist, right? And so it became, how can we, some watch companies start looking at this, and they're like, how can we get that small enough to fit on a wrist? Well, fast forward to the 1960s, and the Japanese company, Seiko, they're just determined to make something small enough it'll fit on your wrist that uses a crystal inside. And they work on it, and they work on it through the 60s. Finally, in 1968, the president of Seiko says, okay, you have 1 year, and we need this to work in 1 year. And he got all the best engineers. He said, work on this watch. And they, on Christmas Day in 1969, they put out the Seiko Astron. And it was the first quartz watch. Not quartz like it has a shiny crystal window, but actually inside. And it turns out they used a tuning fork, but it wasn't made of metal. It was made of crystal. And they had a really ingenious way of making it move the second hand. What they would end up doing, the speed wasn't this in their original one, but what they would end up doing is they would make their crystal vibrate at 32,768 times a second. That's an interesting number to choose. I don't think they pulled that out of a hat, though. What are they doing? Well, it turns out they have it vibrate at that rate, and then the little electric blips that sends out, they ran it through what they called a flip-flop. And this flip-flop circuit would halve the blip. So it would take that big number and halve it. And they ran it through 15 flip-flops. And guess what? That number divided by 15, you get down to 2. And then they ran it out, the last flip-flop, cut it 2 in half, and you got 1 blip every second. And the little blip would push the second hand. And every second, the crystal would perfectly push the second hand, 1 blip. And when this came out, they said it just shook the watch industry. Like, you had those Swiss watchmakers who have those, they work so hard to make their spring-loaded mechanisms work so, it's like if you were a swordsman and you had the best, sharpest swords and you showed up to the battle and somebody brought a lightsaber. It was like, can you imagine a Japanese Jedi? Anyway, we're not gonna go there. Oh, Japanese. Okay, but all of a sudden, everybody had to race to start making these quartz crystals. And then the price came down. And all of a sudden, all of the watchmakers started looking at this. And you had watches that instead of drifting seconds every day, they would take months to drift that amount. And the accuracy just changed the entire world of timekeeping. So if you have an idea and a goal, science and engineering just might bring it into its time. Thank you.
Well, it's time for me to introduce the creator of Acellus, Dr. Roger Billings. You know, a few years ago, when the U.S. Army needed a faster network, Dr. Billings and his team developed a nano latency 100 gigabit network. And this was something that took the network speed measurement, you know, how long it takes to go from port to port, from thousands of nanoseconds down to under 100 nanoseconds. And today we use that same technology in Acellus data centers to make them run super fast. No wonder they call Acellus a learning accelerator, huh? Please welcome Dr. Roger Billings.
You know, last time we got a comment that came in, and by the way, we do get a lot of comments.
We sure do.
And we have a wonderful guy named Darius that is monitoring the comments live and figuring out which ones to forward to Dr. Page, and then she looks at them and she decides which ones to forward to me. And she does it right the worst time, so I lose my train of thought.
I've noticed that. That is true. Guilty.
Thank you. But at any rate, we had a comment last week from Adeline from Indiana.
Yes. Yep.
And Adeline wanted to know what was my favorite invention. And you know, she kind of hit a nerve, because the invention that I think has had the greatest positive impact on planet Earth and eventually on Mars community
I like that.
was an invention that nobody understands. And some people that are close to me kind of know what I call it. I call it FSD, which is an acronym for Functionally Structured Distribution. Oh, really? You invented that? What is it? So, after last week's ScienceLive, couple years, after last week's ScienceLive, I says, so, can you tell me how FSD works? Can you tell me what the invention was? She had no idea.
Oh, I didn't know.
And then I realized hardly anybody understands FSD.
I know the patent number.
And I thought it might be interesting to kind of tell about it. And this invention goes way, 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 way back. It's something I did a long time ago. I think it has really changed the world, at least the computer world that we all interact with today. It was valuable. Some of you might be interested in knowing that I patented this idea, and then I donated this patent to IST, to the university here, that then created Acellus. So it was really this patent's fault, or this technology's fault, that a lot of the things we're doing were made possible, right?
Yes.
So would anyone be interested in trying to get into this? Why don't people understand what it is? Well, it's kind of hard to understand. And to me, it isn't. But the reason that I was able to understand it is because I did what my mentor, Bill Lear, taught me to do, and that is to try to understand a problem that I'm trying to solve. If there's something that needs to be fixed, and we need to invent a solution to fix it, you have to really understand the problem. And what was your name again? Oh yeah, if Page Monet is going to understand FSD, then she's got to understand the problem it was trying to repair. So I would like to invite you to join me on an adventure to see if we can understand this. Now it gets a little bit technical, but I think if we go just at the right speed, you can keep up with it, kind of understand. So I want to show my first slide. I call this invention universal networking. And you can see there's the patent number, 4,714,989. And if you read the description, universal networking is a technique for seamlessly and securely exchanging information across an unlimited number of computers at optimal efficiency. Now, see, that's kind of, wake back up, come back. So let me explain what this is. This universal networking is a way of sharing information between an unlimited number of people. As many people as we get on Earth, it can handle. Plus, we can bring in the whole universe. That's why we call it universal networking. So I'd like to start out by explaining the problem, and then I'd like to get into the solution. I'd like to tell you a true story, a very true story, about a gentleman named J. Willard Marriott. He's that handsome guy right there sitting on his desk looking like, man, am I going to change the world? And Mr. Marriott was the guy that created the Marriott Hotels. I had the opportunity of meeting him in his home way back in the last century. And he's passed away now, but he created one of the, if not the most successful hotel chains in the world with many, many, many hotels. And next to Mr. Marriott in this picture is the IBM 370 computer. This is a mainframe computer. Look how massive it is. Fills a whole room. And the one that was being used by Mr. Marriott to schedule out of his hotel rooms so that people would be able to book a room was the Model 195. Now this was kind of the second generation of the big mainframes. The first was the IBM 360, and then the 370 came out, and it had a lot of different models. The Model 195 was the biggest one that IBM made at the time. So, as Mr. Marriott explained to me his problem, I came to understand a real challenge that needed to be solved by an inventioneer. And I thought, if I could solve this problem, it would change the world. Now, to just kind of set the stage for this, the people at Intel had developed a chip that was a whole computer in a chip, a whole computer in one chip, one electronic chip. Had lots of transistors and all of the different parts, but one chip. And to me, that said, now, instead of just having a big giant mainframe that costs millions of dollars, we could afford to give everyone their own computer. At that time, when I would say that to people, they'd look at me like, you're crazy. In fact, the Wall Street Journal ran a front page cover story when I announced this, saying how crazy I was to think that. They never did a retraction.
No vision.
Maybe I should remind them of that. But anyway, they thought I was crazy for saying that. And they also said I was going to make hydrogen. Anyway, they gave me a very hard time. Well, this mainframe computer was very, very powerful. It was the most powerful computer that businesses could buy. And it has a central processing unit, which is kind of like the brain of the computer. In fact, here's a little diagram I made. You see up there on the top, it's called the CPU, the Central Processing Unit. That's the brain of the computer. That's the part that was in that chip that Intel made as a CPU. When IBM made their mainframe, they didn't use an Intel chip. They did it the hard, old-fashioned way, and that's why it was such a big monster. But you have a central processing unit, and for those that are still trying to understand how a computer works, think of that as the brain. That's the part of the computer that does the thinking. Then you have the memory. So memory is a place that the brain can store information and retrieve it. So it's a way of remembering it. It's like having a notebook that you write things down so you can look them up and say, oh yeah, I remember what I said. All right, you with me? So that is a computer. Well, in the IBM 370 mainframe, they put as much CPU as they could. They put as much power as they could. And then, to be able to handle a lot of users simultaneously, they started by having the users punch cards, little holes in cards. They had a machine you'd type in and it'd punch holes. And when I was a university student, we had an IBM 370 mainframe, and I was doing research on my hydrogen car. And when I was programming the program I wanted to run, I did it by punching holes in these computer cards. And I have a whole box of these cards, and I'd take them down. I'd give them to the girl through the window because they wouldn't let me in where the computer was, which I thought was not nice. But anyway, and then I'd come back the next day, and they'd give me a printout of the result that had happened. And quite often the printout would be, sorry, Charlie, your program didn't run because one card's missing.
Oh, whoop.
And I said, oh, that card was upside down. Turn the card over, run it again, okay? Well, later they got fancier, and they found that you could make a terminal. It was a screen and a keyboard, but it was no computer. It was just a dumb terminal, a TV with a keyboard that had a cable going into the mainframe, and you could hook up 50 or 100 or even more of these terminals. And anybody could get on a terminal and type stuff and it'd go right into the computer. So mainframes had a lot of terminals, but the CPU in that figure did all the thinking for all the terminals, and it could only think about what one user was doing at a time. So it would do this one and then it would do that. Multitasking was kind of a problem back there, so it was limited by how many people that it could run the program for, okay? So that's why they kept making them bigger and bigger and bigger and bigger and faster. Well, Mr. Marriott told me that he had a major expensive problem at Marriott. And Marriott wasn't as big as it is today, but it was already giant. And he says, we have hotels all over, and people are wanting to reserve a room. It's really a problem if they think they have a room reserved, they arrive, and we're full. So what we do is we reserve, and we use the IBM mainframe to keep track of all the rooms and what days they're available and when people are checking out and so forth. Well, here's the problem. They got the biggest IBM 370 195 computer IBM could build, and they started scheduling the rooms, and they connected over data terminals out to all the hotels. So if someone contacted the hotel and says, I want to book a room for April 10th, they could do it. But they also had a toll-free telephone number people could call to book a room. And most of the people called the 800 number. Now we do it over the internet, but then it was called the 800 number to book it, but some booked it by calling the hotel property itself. And somehow they needed to know how many rooms the 800 number was scheduling, because if they both sold the same room, they got a problem. Can you see what I'm saying? And here's the deal. The computer couldn't keep up. And so it started taking longer and longer. Just imagine you're on the phone, the 800 line, people called in, hi, I'd like to book a room for Dallas, Texas at the Marriott Hotel there. So, okay, well, just a minute. You punch into the computer, sends it to the mainframe. Okay, what day did you want? Okay. Well, let me see if we can make that reservation. Then you send it. It's coming. The operators had to become very good at thinking of things to say. By the way, where are you calling from? What's going on? How's the weather? Nothing back yet, nothing back yet. And Mr. Marriott said that it got so bad that they had to separate and put one computer for the 800 number and another computer for all the hotels to book. And then the problem was they could only book half of the rooms, and maybe on the 800 number they had someone that would take a room, but they were already out of their half. So anyway, had a lot of vacancies. So then IBM was good enough to develop a way for them to have two computers and have the computers share information. And that's what we get into with this next slide. Can you see we've got an IBM mainframe, and we have an IBM mainframe, and they are both sharing information because they've got to know what each other was doing. If you look at the first mainframe, there's 5 different ports, which meant it could connect to 5 different computers. And the other one had 5 different ports, so that they were able to actually send information back and forth between 5 computers. But inside of the CPU on the left, you've got memory. And that memory is a finite amount of memory. And what you do in a computer is you put a program in you want to run. So they had a program to talk to the other computer to be able to share back and forth information about who was booking rooms and who was canceling rooms and so forth. So you had to have a little block of memory for every single computer you were talking to. And then you had to have a communication module to be able to talk to the other computer. So you never knew, now in this diagram there are 2, but it actually shows that you could have 5 of these mainframes all sharing the information back and forth, so you can make a much bigger computer by networking them all together. And Mr. Marriott told me, we now have 12 of IBM's biggest mainframes, all sharing information back and forth, but the wait on the telephone is way too long. It's costing us a lot of money, we're losing a lot of reservations, and so we told IBM, we need a 13th computer. But IBM told us that if we hook up a 13th mainframe computer, it'll slow everything down. Because all of the memory of talking to 13 different computers simultaneously will overload its capacity. So 12 is the maximum they can do. And he said, and we're still growing. So you see they had a very interesting little problem on their hands, didn't they? I want to now show you what happens if you have 13 computers. Now they just can't keep up, and the machines lock up, and the memory gets overloaded, and they're doing a thing called thrashing. And so they had a limit. He said, we need a bigger computer. We need to be able to have a lot more people be able to book these hotels. And I hear you're working on an invention that could solve this problem. Now, I came at this problem from another direction. Before I even met Mr. Marriott, I saw that CPU and I thought, now everybody's going to have a computer. So we don't need a computer that can do 13. We need a computer that can do billions of people simultaneously, and they can all share information securely without it ever getting lost and without the mainframe being overloaded. And so I came up with this simple concept. And wouldn't it be amazing if a real simple idea could solve this nightmare? You could try and make a bigger computer, but it just gets hard. That machine was so big and crazy, it just gets really hard. And it was trying to be ready to receive queries from all the other computers because it never knew when they were going to come. And I thought about it and thought about it. And so I came up with this. This is my idea of how to solve the problem. On the left is a personal computer. It's got a CPU and memory, just like before. It's got a way to talk to the world, but instead of talking to the world, it just talks to the internet. We didn't call it the internet there. On my invention, I just called it the network. But the data goes through the internet, but it can be addressed to any other computer anywhere in the world. Now, if I talk to another personal computer, and you could, when I was doing this invention, the technology existed to do that, but you'd have to call up the other person. Like, I want to talk to you, okay? Paige, I'm going to send you a picture, okay? Are you ready?
Yes.
Sorry. Have you loaded your receive program? So she'd have to go find a program called receive. Did you get it ready?
Yes.
Okay, because I don't want to send it before you're ready or it'll be lost in space. And that's exactly what would happen. You ready?
I'm ready.
Okay, send. Did you get it? And you could send from one computer to another, but that's how you had to do it. And if you didn't start the receive program, let's just say you leave it running all the time, well, you'd have to have receive from Roger, receive from Grandma Jones, receive from Tom, and your computer would be completely busy like the mainframe. But with my idea, I said, you know what? What about a library? Libraries have a librarian and a whole bunch of books. And wouldn't it be crazy if you want to read a book and you live in a big city like New York and you know that somebody in that city has the book you want, so you go knocking door to door. Do you happen to have Tom Swift Jr.? Okay, thank you. Do you have, you see what I'm saying? It's crazy. So what we do is we set up libraries. And in libraries, we organize all the books we have. We even have an index card to help us find it. So you go to the library and they say, yeah, we got it, but it's checked out, come back in a week. So we come back in a week. But the librarian helps us share books. You don't have to go door to door knocking. We could do the same thing with computers. We will have a library computer, which I called a data center. The people that wanted to infringe my patent without paying royalties, they decided that's not a data center, that's a server. Because there was a thing called a file server. That was a box that you connected to a single computer. It didn't share information. And so they figured, we're just doing that. We don't have to pay him royalties on his patent because we're just doing a server. Well, turns out they did have to pay royalties because a server, a file server, doesn't solve this purpose, and I'll explain why. So we call it a server today, and that's all right with me. You can call it whatever you want, but my patent calls it a data center. And what it does, it's a computer that just spends its whole life waiting for someone to want information or to store information. It's like a library. Libraries aren't there because a library wants to read a book. They're there to have books for people that want to read them. And they're just always, 8 o'clock we open, we're ready. Anybody that wants to can come in and find a book, and then they can go and they can bring it back, okay? Well, that's what this library server would do. It would be always in the mode of waiting for someone to send something or for someone to send a request for something we have. And by having that, the user computer didn't need to have all those connections to all the other computers. So in the case of Marriott, we could put a personal computer at every one of the telephone operator desks and at every one of the hotels throughout the world, and they could both talk to a server, which would then just keep track of all the scheduling for everybody. And if it got too busy for the server to keep up, they could add another server. They could have a server for every single hotel because any personal computer could go to whichever server they wanted. And by the way, that's what they do today. Yeah. So this eliminates all that congestion, and it makes it possible for an unlimited, an infinite number of people to be able to share information securely and reliably. Now, I hope you're still kind of with me. There was a company that was in the business of creating a product for a certain niche market, and they were about 2 miles from my company where I was building these computers, and they heard what I had, so they decided they wanted to copy. And my patent took 5 years to get approved by the patent office. And during those 5 years, they started building these systems using universal networking, infringing my patent, which wasn't issued, so I couldn't enforce it. They hired a lot of my people, my programmers. They hired one of my vice presidents. Then the patent issued. And when the patent issued, they had been selling my invention to the tune of about $2 billion a year, because it was a pretty hot invention. And when the accountants calculated how much they owed me in royalties. They owed me $900 million. Well, they weren't real happy about writing me out a nice check for $900 million. I said, well, this is going to help the Acela students someday. No, they didn't. So we got in a big lawsuit. We got in a big fight about this. And this company had a chief scientist that said he had invented universal computing for them. He didn't call it that, but he said he invented it. In fact, he sold that invention to them for millions of dollars of stock. And we took his deposition as part of the lawsuit, and we found out that he didn't even know I was building computers. He didn't know anything about mine until we found a paper where he went to university that he said, I visited the Billings Computer Company, and what they have is going to change the world. Oh, goodness. When we pulled that out, his countenance changed. And he says, so you never did know about Roger and that he was in the computer? Well, yeah, I did know. Well, how did you know? Well, I saw him down in Dallas, Texas, when he announced his big new system. But he got up there and he said, you can connect an infinite number of computers. You could connect computers for every person on the planet and even from Mars to the same system with this invention. And this is the guy that got paid about $100 million for selling my invention to that company. And he heard about it the day I launched it, which is a great way to invent things. And then he said, but we knew Roger was crazy. So we just, and I'm quoting it, we just blew him out of our heads because we knew you couldn't connect everybody in the world on the same system. Of course, he hadn't heard about the internet yet, which is all based on this system. Anyway, turns out that in the course of that lawsuit, they either needed to write me a check or they had to come up with some legal gimmick, which they did, or they had to change their product. My patent says if you're going to use this invention, you have to do this and this and this and this. And if you do that, that's my invention, it'll work. And they did this and this, and they followed it perfectly. And they were extremely successful. But when we got all ready to go to court, they released a new version of their product where they changed one thing. So their new product did not infringe my invention. That company's gone. Because they changed that, their product failed.
Didn't work.
It didn't work. Attorneys call that commercial success. It proved that the invention was, in fact, the secret behind their success.
That really proved it right there.
Yeah, so that's kind of FSD. And that is the source of funding that launched our university, the IST, and eventually led to the development of Acela and a lot of other things. So I hope that's kind of interesting to you. So here it is. This is universal computing. The model there on the left.
That handsome gentleman with the chrome.
Yeah, that is
chrome.
me back in the day when we were launching this thing, and I'm just being held up by one of these first data centers.
Wow.
And this machine was able to store the information like a library for an unlimited number of user computers. And on the right, you can see the Billings Microcomputer, which is one of the very, very first personal computers which connected to these. And we installed these at places around the world. And until I sold this company, it was actually very beneficial to me. And it's a chapter of my career that I'm very proud of. But today, the whole internet is based on the principles of that patent. And my patent is run out. Needless to say, they only last a few years, and that's the idea of them. But I feel like we contributed something that was beneficial. kind of to the world. Now, we're almost out of time, but before we finish, I want to get back to one other thing. I've been receiving a lot of personal mail from students and parents and even grandparents about the Roger Billings Scholarship. And some of you have been receiving letters from Mr. Joshua about the scholarship, because as you know, there is a requirement if you're going to be on the Roger Billings Scholarship, where I help pay some of your tuition, that you've got to study hard. And one of the things I require is that you spend an hour with me once a week so we can talk about why you ought to study hard and how much it's going to enhance your career. Well, most of the students do. Some haven't been diligent. Some haven't been doing it at all. And I've kind of let it ride. I've even had parents post, ha, 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 we don't do it, and he never checks, ha, 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 ha. And that really hurts my feelings. And I feel like turning them off. Ha, ha, ha. But you know, that's the parents. But I just think, why would they promise they would do it if I would pay 70% of their tuition and then not do it and then brag about it and tell other people, you don't have to. You don't have to do it. Well, it turns out that we do keep track of it. And the students that are attending ScienceLive are even earning science credit, which is going to help when they get ready to graduate. But now I have a problem. And that's why we're starting to send out the letters. And that is, who ever could have imagined how much this will grow?
Not me.
It's really heartwarming for me. Makes my heart flutter when I think about all of the wonderful students that are participating in Acellus, and especially the ones that are participating, hopefully because my scholarship was helpful to help you get it. This is something that I don't always do, but I think today it'd be kind of interesting for you to know it a little bit from inside.
Rare moment.
Rare moment. So I want to show you this next slide. The Roger Billings Scholarship this year, 2025, has cost $141 million. And some of you guys, that's chump change. To me, that's quite a bit of money. And I'm at a point where I now have to cut back on it. And so as I start cutting back, I've got a lot more students who want scholarships. And I look at the students that have the scholarships that aren't really using them. And it's interesting, the students that aren't keeping their promise of watching ScienceLive seem to be the students that aren't that serious about their studies. I'm willing to help a student out if they're willing to really study and work hard, and if they're willing to come in and talk about studying once a week for an hour with me. And so that's what I'm going to do. I'm going to start cutting back on the people that aren't living up to their promise that they will watch ScienceLive. Now, I'm not saying they've got to do this every week religiously. I think that's crazy. But right now I'm saying they ought to at least do it half the time. And I hope even a little more. I hope they can see some value in it. We are seeing that the students that do it regularly seem to understand the value of education, and that's my goal. So you parents, you might want to think that maybe this has some value to your kids. But I'm willing to put my car that I really, really enjoy up for sale. This is me. This is coming in here tonight. And yeah, that's a Rolls Royce. And I really, really, really enjoy driving it. It has 8 cylinders, except when I need it, and then it has 12. Yeah, it jumps up to 12, and boy, can it get up and go. It's a car that just kind of glides around.
Is it the Ghost?
And it's a Ghost. Yeah, Rolls-Royce Ghost. And it's a car that was so quiet that people complained they couldn't tell if it was running or not. So the Rolls-Royce people, according to the story, made it just a little bit noisier so you could barely hear the engines run. But it's a wonderful car, and I really enjoy it. I'm willing to give up that car and get some old dirtbag Mercedes or Ford or something if it will help more kids study.
Because you really care.
But I'm not going to do it if they're not willing to really live up to their commitments in doing the study. And it gets worse than that. It would be a lot harder for me to give up the jet. You know, Bill Lear, our mentor, invented the first business jet. And we flew all over in his jet while I was being mentored for a year. And I kind of found out that's a real nice way to travel. Well, this is the little puppy. You'll notice it has 2 jets. There's another one hiding on the other side. It's a 3-jet, so it can go out over the water and do a lot of things. And it can carry a nice team of people. And we've been able to use it for a lot of business purposes. And it'd be harder to give up the jet than it would the Rolls Royce. But I would do it if it was going to change the life of our Acellus kids. So I'm willing to make some sacrifices. But you parents and you students, I'm going to ask you to make some sacrifices too. And what I'm asking you to do is to invest in your future by getting a good, solid, strong education. And it may seem like just a lot of work. I'm thrilled that a very significant, way above average % of the students that watch ScienceLive essentially every week are graduating with honors. Yeah. If you graduate with honors, that means you're taking the really high rigor versions of our courses. We have people that say Acellus doesn't have rigor. We have a version that has lower rigor for special education students because you got to deliver this to people at the level they can handle. But then we have the normal level, which is the rigor of all the standards, and then we have the accelerated mode. And a lot of our students are doing that, and they're going to be prepared for great things in their lives. And I think that's just really an interesting thing for you to think about. So I don't know, what's your greatest invention? This is maybe my greatest invention so far.
Love it.
But stay tuned, okay?
Okay.
And I guess others have their inventions too.
Oh, yeah?
Hello, guys. I want to welcome you to Area 51, where science comes alive. Being a scientist is so exciting. My whole life, all I ever wanted to be was a scientist. And then one day, the big R just turned on my switch. And it was a scientist. And so I'm just really excited about today to have you in Area 51. It's so good to see all of you again. And today we have something very special because little old R51, he got mail. He got some mail. And we're going to read my mail right here together. So I'm going to open up the mail. And there it is. Oh, it's from one of the students. That's so sweet. Dear, that's me, I'm dear. R51. Want to see? It's the mail. Dear R51, what was your greatest invention? Oh, man, that's a hard one. Do you have any idea how many inventions I have? That's kind of like an infinite number. It's so big. Ooh, it goes clear beyond space. I invented the little pay-go-round. I invented the radio transmitter. I even invented the spin-her. The Page spin-her. Do you remember that? It's the Page spin-her. I've invented so many things. But I'm going to let you in on a little secret. They're nothing. All of those things, they're just nothing compared to my biggest invention. And this student has taken the time to write Dr. Well, maybe not doctor, but R51 is just like a doctor. And they said, what is your greatest invention? So I'm going to tell you a little secret. Does anybody like ice cream? Yeah? What's your favorite kind of ice cream? Oh, don't all talk at once. Oh, there's so many cute little voices. Oh, okay. That one right there. Yeah, that. I'm talking about you. You're the one that said, my favorite ice cream is chocolate chip. Oh, that's just darling. Chocolate chip. Well, it turns out that androids don't eat ice cream, but we do like a certain kind of ice cream. We call it electronic chip ice cream, and it's really, really good. And androids, when they get electronic chips, they're just delicious. So now getting back to my greatest invention of all time, I invented this. This is an android ice cream truck. And you can see they bring the ice cream out to the androids, and they've got this little rotary thing up there so they can find the androids. And the kind of ice cream that they give us is electronic chip ice cream. And that's why we have this very, very, very special ice cream truck. And, oh, I invented it. And that's why I am such a special android. All of you androids out there, if you ever want to have my ice cream electronic chip truck come see you, you know how to send me coded messages.
Crazy, huh?
Kind of endearing.
To each their own, huh? So the science fair is coming up. Yep. There's just barely time now to do a great project. And you know, my first science fair project, I was germinating seeds. You got to start, and then every year it gets better. So I hope a lot of you will be inspired to think of a science fair project. Thank you. We'll see you next time.